Hi guys, welcome back to my video. I am Sujit Dharma playing today's show for the name and my section is Devo and my USN is 1B 2 CA040 and my semester is consumption and my subject is applied condition for CSST. My subject code is BCHESC and my comment on my topic is understanding corrosion and electric systems. Coming to the corrosion part is definition of corrosion is it is basically defined as natural process that causes conformation of pure metals into undesirable substances when they react with substances like water or air. This reaction causes damage and disintegration of the metal, starting from the portion the metal exposed to the environment and spreading to entire bulk of metal. Now, coming to the next part is types of corrosion. Types of corrosion is number one is surface corrosion and stress corrosion cracking. And third one is intergranular corrosion and fourth one is galvanic corrosion and fifth one is uniform corrosion. Now, coming to first surface corrosion is whenever there is a difference in ionic concentration between any two local areas of the metal, a localized form of corrosion known as surface corrosion can occur. For instance, this form of corrosion mostly occurs in confined spaces. Examples of area where surface corrosions can occur are gaskets under the surface of washers and bolt heads. All grades of aluminum alloys and stainless steels also undergo surface corrosion. This is mainly because of formation of different adhesion cell that leads to formation of corrosion inside the houses. Coming to second one, stress corrosion cracking. Stress corrosion cracking can be abbreviated to SCC and refers to cracking of metals. As a result of corrosion environment, the tensile stress placed on the metal it often occurs at high temperatures. For example, stress corrosion, cracking of austenitic stainless steel chloride solution. Now, third one is intergranular corrosion. Intergranular corrosion occurs due to the presence of impurities in the grain boundaries that separates the grain formed during the solidification of the metal alloy. It can also occur via the depletion or enrichment of the alloy at this grain boundaries. For example, aluminum-based alloys are affected by IGC. Coming to both this galvanic corrosion. When there is existence of electric contact between two metals that are electrochemically dissimilar and are in electrolytic environment, galvanic corrosion can arise. It refers to the degradation of one of these metals at a joint or at a junction. A good example of this type of corrosion would be the degradation that occurs when copper in a soil water environment comes in contact with steel. For example, when aluminum carbon steel are connected to immersed in seawater, aluminum corrodes are faster and steel is protected. Coming to last type is of corrosion, that is uniform corrosion. This is considered the most common form of corrosion, wherein an attack on the surface of the metal is executed by the atmosphere. The extent of corrosion is easily discernible. This type of corrosion has a relatively low impact on the performance of the material. For example, a piece of zinc and steel is immersed in diluted sulfuric acid would usually dissolve over its entire surface at a constant rate. Coming to now corrosion prevention techniques. And the corrosion prevention techniques, it consists of four types. And number one is galvanization. Galvanized metal is coated with a thin layer of zinc to protect it against corrosion. The zinc oxides when it exposed to air, creating a protective coating on the metal surface. And number two is alloying. It's the method of improving the properties of a metal by mixing the metal with another metal or non-metal. When iron is alloyed with a chromium and nickel, stainless steel is obtained. Stainless steel does not rust at all. Painting. Now, rusting of iron can be easily prevented by coating the surface with paint which protects the iron from air and moisture. Greasing or oiling. When some grease oil is applied to the surface of an iron object, then air moisture cannot come in contact with and rusting is prevented. Now coming to next slide of the electrochemical principle. A redox reaction are the basis of electrochemical cells using the energy generated by a chemical change and a spontaneous redox reaction. It generates electric current. Both electrodes and electrolytes may be the same or different in two off cells of electrochemical cells, which is why they are called off cells. Electrochemical cells are made up of the following components. There are two types of electrodes, conductors and dielectric electrodes are electrochemical cells, solids, metal, electrical conductors. These are two kinds. To put it simply, here with oxidation happens in the cell. The cell compartment where reduction takes place is referred as the cathode, and where electrode is dissolved in polar solvents such as water, it forms ions where are electrically conducting solutions. To complete an electrochemical circuit, a salt which joins the oxidation and reduction helps. Salt solutions such as KCl filled with gel. Now, electrode potential. The electrode potential is the voltage of galvanic cell from a standard reference electrode and another electrode to be characterized. By convention, the reference electrode is the standard hydrogen electrode SHE is defined to have a potential of 0 volts. It may also be defined as the potential difference between the charged metallic rods and salt solution. Now, cathodic protection. Cathodic protection is a technique used to control the corrosion of a metal surface by making it the cathode of electrochemical cell. A simple method of protection connects the metal to be protected to more easily corroded sacrificial metal to act as anode. The sacrificial metal then corrodes instead of protected metal for structures such as long pipelines where passive galvanic cathode protection is adequate and external DC electric was also to provide sufficient current. Next one is corrosion monitoring. Corrosion monitoring is the use of corrotor or set of methods and equipment to provide offline or online information about corrosion rate expressed in MPY milli per year. For better care and take or improve prevent measures to combat protect against the corrosion. In this article, the difference between corrosion monitoring and corrosion protection is difference the corrosion inspection and also the understanding between them, as well as online corrosion monitoring methods equipment used and applications of each them are presented. Now, conclusion. Understanding the corrosion and electro systems is essential for preserving the integrity of structures and equipment. By applying appropriate prevention techniques and monitoring methods, the detrimental effects of corrosion can be minimized, leading to be improved safety and longevity of materials. I hope you liked my video, and carries my marks. Thank you for watching my video.